Okay, awesome. Well, welcome everyone to the September 2021 PyData Triangle Meetup. Glad to see everyone's joined after so long.
I was saying we had 120 RSVPs. I was curious to see how many people were serious about it.
Yeah, maybe the numbers will go up as we start the presentations. But yeah, thank you everyone for joining. First off, I'd like to thank the sponsor, used to be Velas's Digital, now Veracast, data-driven marketing communications. So thanks Veracast for sponsoring.
And it used to be a bigger deal, you know. Right now, all I have to do is start the Zoom meeting, and that's it. You know,
Yeah.
Before it used to be like a buffet in a room, and all the good stuff. But we'll get back to that eventually, I'm sure. We're trying to open our offices before the end of the year, but I'm just not sure where we're going to get back to, breaking bread together. But sooner the better.
Yeah, and I guess for now we have the Zoom link.
Hit the Zoom link.
Yeah, and thank you to our other sponsor, NumFOCUS. NumFOCUS is a nonprofit that promotes open practices in research, data, and computing. Yeah, as always, I'm sure you've seen the code of conduct before, but as a reminder, PyData is dedicated to providing a harassment-free experience for everyone, so please be kind and professional. As we always say, don't be mean, be above average. And a quick reminder that our next meeting is November 3rd, 2021 at 6 p.m. So we're still a bi-monthly conference at this time. Yeah, I just wanted to take a moment to ask everyone, like, how can we best serve content that you want or need? So what data science topics interest you? Do you know anybody who would like to present on a talk? Are there any activities you'd like to organize? Any local data science resources that you want to engage with? We're really looking for presenters to fill slots for the next few months, actually. So if anybody you know or you yourself are interested in speaking, please reach out to Mark, Dhruv, Jean, or I via Meetup or email or LinkedIn, and we'd love to speak with you.
I want to make a point that it does not have to be a long presentation. We are very flexible, especially while we're online, about having smaller length, shorter length presentations, 20 to 30 minutes, as opposed to an hour or more.
Yeah, definitely. Yeah, I also wanted to ask this at the beginning. As you guys know, the last 15 minutes or so is dedicated to lightning talks. And so a lightning talk can be like a 5 to 10 minute or even less than that talk ranging for any data science topic or in any format. So this could even be like sharing something interesting you learned this week. So if anybody is interested in speaking for a few minutes at the end of the conference, please let me know in the chat and I can create a list of speakers. Yeah, and finally, I wanted to take this time to ask everyone, does anyone have any event announcements or job opportunities they'd like to share?
Well, Veracast has 2 open senior data scientist positions, and I believe there's a couple data engineering and software engineering positions open in various places. Most of our positions are remote now, so I know most people here are local, but you could see our open positions on the Veracast website.
Awesome. Yeah, and I actually got a message from Taylor England from Rasgo. They are looking for a strong Python developer who are interested in data science and machine learning. It's a remote job opportunity, and I've posted that link in the chat as well.
Yeah,
Yeah, so Elucid Bioimaging, ELUCID. We're hiring a Python, sort of a Python developer, senior Python developer, I believe. And there's a contract and full-time role. The full-time role is in Boston, so you'd have to be willing to relocate to Boston. But I think the contract role may be remote. So yeah, that's another one. And it's ML-ish. I mean, it's not doing ML directly, but it's working more sort of on the engineering side. But it's ML adjacent.
Awesome, thanks.
Sure.
Yeah, anyone else? Cool. Yeah, otherwise I guess we can get started.
Hey, oh, sorry. Hey, this is Matt Meinl. Yeah, I work for a company called Bodo.ai. We just got our Series A closed this week. We're hiring a bunch of Python people. We basically do auto parallelization for pandas, for Python pandas. It's like a big compilation engine, compiles your Python, makes it parallel, speeds it up. Apple's using it. It's a pretty big deal.
Great, thanks. Cool. Yeah, let's get started on our presentations. So first up is Daniel Wagner. Daniel started his career on mobile app development and has since then built countless large-scale e-commerce and CMS projects before diving into the world of fintech in the last 5 years. Daniel currently leads the data and AI team at Sensible, and he'll be talking about building a state-of-the-art inference pipeline on AWS SageMaker. Daniel, take it away.
Hi, everybody. Thank you for having me. It is Daniel. Let me share my screen. So sorry for the mouthful of the title. I was preparing for another conference and they had, let me just present, I'm going to presenter mode. And they had that as a suggestion of the topic, so I took it, but I now realize it's very of a mouthful. So I'm going through the presentation. Please feel free to stop me at any time, ask questions. It's going to be very, very boring if I'm talking by myself for an hour. So stop me at any time, ask questions. Should be reasonably interactive. So let me start quickly about myself. So on the personal side, try to like biking. This is me on a 1 foot drop, being terrified. So I like biking and necessarily good at it. As a professional background, I have a master's in engineering. I started my career as a software engineer in a small company in France. Then I went over to lead an office in Brazil, where I'm from. I stayed there for about 10 years. It was mainly focused on e-commerce. Then I left because once you get away from Brazil, about a year after I left, they were bought over by Capgemini. So I guess my leaving helped. And since 2016, I'm at Sensible, started my career here on the delivery side. So Sensible is a B2B company. And so my role was to make sure that our clients were well integrated and that we understand what they were doing and how they could leverage our software better. And then for the almost 2 years, leading the engineering function, more particularly the machine learning team. So yeah, this is about me. This is my LinkedIn. If anybody wants to connect, more than glad to. So want to talk in terms of flow. I'm just going to talk a bit about Sensible, about what our journey has been, talk a little bit about our data, what does it contain, and what stories we can tell with it. Sorry, any questions? Then I'm going to walk a bit, how was our journey to actually build our system from scratch and actually getting bit more details into what we've done, and then opening for questions. But again, stop me at any time. Yeah, don't want this to be 1 hour monologue. Right, so going to briefly go over what Sensible does. So first, talking about who we are, especially being a B2B company, I think it's important to say who we serve. So Sensible is a company that does receipt management for banks. That's kind of the beginning of our journey. So we are deployed with Chase. So if you have a Chase app and you go to your accounts, you should see an option to manage your receipts, and that's us. We also are deployed in the largest fintechs in the US, so NCR, FIS, as well as some major banks in UK, so RBS, NatWest, big presence in Canada as well. So we have over 60 million customers worldwide. Of course, Chase is the largest one. And to them, what we offer is the possibility to do receipt management for their users. In terms of the tools that we offer, is we offer ML-backed receipt capture and management for their users. And so if you, again, are a personal user, what the usage that we typically see is that people take pictures of the receipts and they can be leveraged to do budgeting. So somebody goes to the grocery store every week and they want to try to see how their expense fluctuates, or they want to keep tabs on their costs. That's a typical usage. And there's a very strong use case as well on the small business side, when we see people using receipts for a variety of reasons. So on the screen here, you can see keychain innovation that could either be a personal use case, but we can also see lots of contractors that use our system to add receipts to folders. So for instance, they are doing a work on one address, 83 Delta Lane, and then they can actually go and add all the receipts there. And at the end of this project, they could ask for a refund for the expenses, or they can manage the control of their of the workers better. So those are some of the key use cases that we have. Because of the small business use case, we allow easy to export and integrate into accounting software. So that's, again, a very typical use case. So rather than keeping your receipts in a shoebox, you can take a picture. They are automatically on your bank account. And by being on your bank account, every banking reconciliation is a lot easier. What we can also do with that is do alerts. And so for users, we can do a reminder of when your warranty is going to expire, or when your return window will expire. So by understanding what's on that receipt, we can offer a lot of facility for the user. I see a question, but I think it's for the organizer. So this is, again, what we offer. Let me just put this image to my side here. So given that we are offering that utility and we can actually unpack those receipts, we can actually go and then offer spend insights to the users. So given that we now have a collection and that we understand the users a bit better, so we know that Mark went and bought bananas and apples, and then the next week he also bought that, we can understand a little bit more about him. And with that information, we're not only enhancing the banking, the utility of the banking app to the users, but we're also going to be able to understand the users better. And by understanding the users better, what we can do is start to offer insights. And those insights can be as simple as Mark likes to eat fruits every week, but it can be also triggered to life stages. So we can detect that somebody is likely expecting a baby if their behavior changes, and we can see that now they buy pregnancy-related products, or that we can actually see somebody buying diapers and somebody's trying to be cost conscious. And that proactiveness, that reality, what that allows us is to change the way that the bank connects to their users. So one of the biggest difficulties with banks today is that they're good at actually opening accounts, and they have promos related to, I don't know, give you like cheap credits, or we're gonna give you like an iPad if you open an account with us. But they have a lot of difficulties actually understanding their users and creating a relationship with their users. So banks are falling more and more under the same dumb utility as the telecoms today are, right? Because really nobody cares who your phone provider is. All that you know is that they offer you a landline and they offer you internet, and that's pretty much it. And banks are pretty much going down that path. Banks are just a place where you keep your money, but that's it. Like, people don't have a relationship. And what we're trying to do with this Spending Sites product is allow banks to have a relationship with their customers that's a lot closer to the relationship that Amazon has with their customers. So Amazon truly understands who you are because they have access to all your data, and they actually leverage that to offer you contextualized information, contextualized promos, and that is the type of relationship we're trying to create.
Question.
Yes.
On the slide, you've got life stages, behaviors, triggers, and needs. What's the difference between a behavior and a trigger?
So,
like, what would be an example of a trigger that's not also a behavior?
Right. This is more, this page is a little more focused to banks. When we say trigger, we're typically saying trigger to an action. And so because our system is real time or near real time, a trigger could be, hey, we just detected that somebody bought, I don't know, a luggage, or they just bought a Duke roll, so they're likely going to travel somewhere. You should leverage that insight about the user and offer them travel insurance or something like this.
So that makes sense, but one could argue that's a behavior, but it's fine to call it a trigger. So then what would a behavior be if that's not a behavior?
Yeah, again, this is how we're actually, this is perhaps more market position, but I agree with you that that's a behavior. But on our system, the way that we're calling it, a behavior would be something like understanding your user better. So I know that Ron likes outdoor sports, so he always buy every other week he will buy some fishing equipment so that he can go there. And so the way that we trigger internally a life stage is, hey, I just realized that Ron bought a house or had a kid or a grandkid or something. A behavior is a bit more understanding of the user. I can see that you're an outdoor sports enthusiast, and based on that we can fit you in different profiles. And a trigger will be more like a point in time thing. So that is how we are splitting.
So behavior is kind of like a categorized trigger.
Pretty much. Like, he always buys outdoor hunting equipment or fishing equipment. So that's how we trigger our system. And there's a lot on how the buyers are set up on the bank side. So how they plan to use that data. That's more how we trigger this.
Thank you.
Thank you for the question.
Daniel, I have a question about the size of the banks. Have you found any difference in the kind of user, the sensible user, based upon the bank that they're banking with?
So let me see if I understand. If we can see difference in behaviors based on if somebody's banking with Chase, which is of course a monster, versus Quantic, that is a small local bank. Is that the question?
Right, a small, a community bank, a local bank, a state level bank, mid-market, what a small market bank, as opposed to a national bank.
So the behaviors, we do see behaviors somewhat consistent across the behaviors are a little bit more centered on geography than they are necessarily on banks. So a Chase customer from Chicago is likely behaving more similar to Mid-First Bank that's also in the Chicago area. So that behavior is more there. From our perspective, the way that this data is consumed, though, is very different, and something I'm going to talk later. The way that we pack this over, Chase would expect a lot more raw information, and they want to do a lot of the data science themselves, but somebody like a smaller credit union will need something a little bit more ready. But from a end user behavior, again, it's based on the data that I remember. It's more related to the geography than it is to the actual institution they're banking with. I'm assuming I answered the right question. Please.
Oh, yes, thank you.
Okay, thank you. Right, so this is our products. And so just an example, one typical user that we have on our system, not one typical, one example of a specific user that we have on our system. So of course, names and everything else is fake. But for Olivia, we know that based on Olivia's receipts, she spent over $5,000 over the last 2 months across a variety of merchants. We know that she bought multiple kid meals at fast food establishments, so and some adult meals as well. So she's most definitely a mother. We can see that behavior. We can see that she buys, she's in a teaching profession based on the level, on the books and the details of her purchases. And we know that she's likely trying to do something on the side. So she bought an internet domain, and there's quite a few triggers there. So what we are trying to do here is trying to teach the bank on how to engage with Olivia in a way that's meaningful to her versus, hey, Olivia is 30, and because she's 30, we're going to offer her this home savings plan or this. Now, the behavior can actually be, if we know that Olivia is a teacher, well, maybe whenever there's a new government legislation associated to the geography where she is, we can say, well, if for your tax purposes, maybe you should save these types of receipts, or we can actually give insights, and maybe this type of savings account can actually give you a better return in the end of the year. So that is an example of one user and how the bank can actually start to interact with that user in a way that's interesting, in a way that the banks become more than just utility providers, but they actually become a trusted partners. I think that's a lot of what we're trying to do.
Daniel,
Yes.
I have a question about how they know these things. So is all of this like, okay, so book purchases. So the first bullet, she bought multiple kids meals. Okay, so that came from fast food establishments.
Yep.
How do they actually know what she bought? Like, okay, if you're a bank, and assuming she paid for it with a card, you've got a fast food establishment receipt.
Yes.
You have it itemized into kids' meals versus adults' meals?
Yes. So the way that it works is that, again, this is a fantastic question. Let me unpack a few things. So whenever we're building machine learning, we have to be very much aware of the responsibility of managing data responsibly and how we can actually do things in a way that's useful. Very few people have weird feelings about how Amazon triggers you, because you know that Amazon is offering you, like in my case, like barbecue equipment, because I always buy something related on their website. So I'm not triggered at all that they know that that's an interest of mine. So whilst on the other hand, somebody that gets an ad on Facebook or on Twitter, it's a lot creepier because they are getting that data from different websites and display places. The way that we get customer data is by Olivia taking a picture of her receipts and submitting that to her bank. So the way that we're getting this data is self-declaratory. So Olivia says, I want to manage my finances, and my bank offers this convenient feature in which I can actually take a picture of my receipts, and then I can get the itemized data. And based on this itemized data from Olivia, we can see that, well, she did bought fast food, and then we can actually run classifications on our side and say, well, we can actually see the classification of every single one of her line items, And based on that, we know that she bought a Happy Meal that we could classify as a kid's food in a Big Mac that could be a teenager or an adult. So yes, we do have access to the itemized data, but is on a self-declaratory way instead of there's us snooping around.
Okay, so just to clarify, but if I paid for something with my debit card or my
Yes.
credit card and I did not take a picture of my receipt, would you have itemized
No.
information? Okay.
No.
So all of these, every single one of these 4 bullets comes from them taking a picture of a receipt and submitting it to this app. Basically.
So and you take a picture, yes. So this will be part of your banking app. And as part of your banking app, yes, you can take pictures. The sources can be multiple. You can actually have, if you have an email with the purchase, you can also send that in, or a PDF. Like the sources are the most common, still paper by far, but yes. So
Thanks for clarifying that.
yes. So again, it's important to say, and I saw the questions from Thomas and Johnson. I'll get you a second. So another reason that Sensible chose to offer these services to a bank is that there's very little, people typically trust their banks to do safekeeping of their data. So most people know, well, my bank already knows how much I make and where I spend my money. Typically, they don't feel a weirdness factor about submitting more data. So that is also why this is the path on all the user surveys. People wouldn't object to the banking knowing that information. So the question from Thomas was, what is the incentive to itemize for the consumer? And that is a fantastic question. So first, also, it's important to say that our solution doesn't have the goal of having 100% of anybody's receipts. And the goal is not for everybody to take a picture of every single receipt. People typically take pictures of receipts for specific use cases. So in case of Olivia, what is very clear is that she's a household budgeter, meaning that she really tracks her food purchases, especially every time that she goes out, as well as when she goes to grocery stores. So she's clearly using this as a budgeting tool so that she can actually see and refer what it is. That is actually a quite common use case. There's other use cases such as a warranty reminder. So whenever I buy something that's a larger ticket item, so if I buy something that's more than $500, I can actually take a picture and ask the app to remind me when is my warranty due or when is my return window due. And that allows people just to manage their largest purchase better. So we're getting access to part of the user's transactions in the part that they care about uploading for any of the use cases that I have. That is more related to a personal use case, but from a small business use case, that is actually quite a common. Then the use case is a lot clearer. Pretty much a lot of depending on state legislations, on anywhere that you pay, you have a receipt, you have a purchase that's more than $70, you have to attach a picture of that $70 purchase to your accountant. Otherwise, you cannot claim as a business expense in the end of the year. So for a small business, there are a variety of use cases associated why you get that. You can also use that to actually manage your taxes. So if you are in a country that has a VAT, so a value-added tax, you can actually claim those back. So there's quite a variety of use cases on the SMB use case. Long-term receipt storage, same thing, because we're digitizing and understanding the data. Yes, then they can search and say, well, where did I buy my TV? Was it at Best Buy or Canada Computer or anywhere? You can actually find that and you have that easy access, and that can be used for a warranty or for anything like this. So the other question from Matthew, so this sort of thing banks do already without the benefits. So from a question of complexity, and that so first on how we do, what do we do with the data? Yes, storing the data in compliance and how we're safekeeping, that's I'll tackle that in a minute, but yes, we were built to be bank tough from the get-go, and making sure that we also had good enough provisions to store our data in a way that's safe.
No, sorry, the question isn't safety of the data. Kind of going at the idea that the bank is sort of our friend and just wants to, use this information in only a beneficent and way that helps the customer, right? That's not supported by reality. And so
No,
in the chat, I linked to the
yeah,
huge Wells Fargo fraud case where they,
yes,
systematically deceived all their customers, right? So it sort of puts kind of a sharp point on the kind of the question of just, is there any way to audit how, not the data, it's really more the intelligence that's gathered. And, is there any, I mean, maybe the answer is just no. This is life, and get used to it. But I am curious what your stance on, sort of in any way controlling or safeguarding how banks use this information and ensuring they don't use it in essentially nefarious ways, because
so
they're bad enough without AI, right? What are they going to do when they have this
is a fantastic question. Yeah. So let me state categorically that I don't believe that banks are nice and your friendly neighbor provider, and they just want you to do this to get to be nice to you. Their goal is very simple. They want to increase their margins. They want to increase ROI. They want to sell you more products. So the reason they buy Sensible is twofold. First is a retention tool. Banks are losing customers to lots of alternative providers, and so there's quite a few surveys that if Amazon or Google created their own bank, how many people will move to them? And a lot of people would say yes. And banks are doing this first from a retention perspective. So they are afraid of losing their customers, and they know that if they don't personalize their service, they'll die. So that is number one. But number two is, given that retention is past, how can I make money out of my consumers better? But they know that they cannot make money out of their consumers just by giving you services that you're not going to buy. They have to be able to target you better. So yes, again, the objective is commercial. The objective is to get there, but they have to figure out ways that they're interesting to the users versus just, yeah. In terms of a compliance and how the data can be used, I do know for a fact that this data cannot be used for any loan purposes because the legislation clearly, any legislation around loan and credit scoring and assessment, we don't abide by this legislation. So pretty much if the bank used us to do that, they will be doing a fraud. So I guarantee that they won't use it. The data is the bank's. So in the end, I can't, but I can guarantee that it's something that we talk about when they are integrating, that this data is not sanctioned to a loan perspective. This data is intended to understand the user behavior better, but you cannot say, well, Matthew really buys, I don't know, way too many expensive things. And so I don't believe that he's a good spender. So therefore, I'm going to lower his credit score. This data cannot be used to do that. This data can be used to understand Matthew better, but like they will be committing fraud if they essentially. So again, again, the user is the bank is the bank. So again, they will be outside of regulatory compliance. So the way, again, the reason that they are using us is to understand their customers more. From GM Nasmus, so does it need to use to, yes. So right now, the only way, so we are part of the banking mobile app. So we're part of the Chase app and other banks app, but do the user, the submission of the data is volunteer. So is Olivia that decided to upload her images for her own purposes. Thank you for the questions. And
Yeah, thank you.
Yeah. So very quickly, a few stories that the data tell. So the other way that we can use this data, that is that we're authorized with our contracts to use it. So from a contractual perspective, the data from the bank belongs to the bank. What we can do with this data is to use that for global reporting. So once we raise who the bank was, who the person was, we can still take a look and see trends on that data. So some interesting things in terms of consumer spending, looking into how the spend data is fluctuating based on consumer spending in terms of types of things people buy, we can clearly see that the behavior in 2021 is definitely looking a little bit more like the behavior of 2019. And so we could, for the first half of the year, it was very clearly that 2020 was completely odd. So we have this report that we publish every month, which is called the barcode report. So you can go to our website and look. So again, it's just anonymized use of the data and just some cool usages. So something else that we did last month was taking a look into how pet purchases were affected by the pandemic. We do know there was a huge increase in pet spend. Lots of people got pets during the pandemic. The adoption, like essentially you could not adopt a cat because or a dog because they were run out anywhere because people, I guess, were home and they had to adopt. So with a banking data as it is, without SKU level data, all that the banks can tell is that there was an increase in pet related spend. But with our data, one, we can understand that your purchases at Walmart were different because now you are buying litter, now you're buying toys. And when you go to a specialty store, we can actually understand more about the user behavior. So we can see that, yeah, litter was by far the thing that increased the most last year, but toys, special diet food, all those things are also very clear on the data. And those are things that we can see based on receipt data, based on SKU level data. So any questions here?
Sorry, is the percentages on that graph just like 100%, like it doubled if it's 100%? So
Pretty
treats
much.
doubled year over year?
Yeah. So the overall, I think the pet consumer spend was more than doubled. This is pretty much how it broke down. So yes, like a 0% will be the baseline. So 30% increase compared to 2019. So 30% increase in 2020 on leashes and collar, double number of treats, double number of normal foods.
Gotcha, thanks.
Sorry, the leashes didn't decrease, the leashes only increased by 30%. Sorry, the baseline is a bit confusing. So now that I explained just a bit what was how the Sensible came to be, who do we serve, and how do we serve, let us unpack a bit on how we build our system and what we actually how do we go about it? How did we went about it? So let's unpack the receipt a bit. So receipts are extremely dense pieces of data. So this is just like our UI to do labeling. So this is pretty much our system just tokenizing a receipt. And a receipt can have up to 151 data points, which is quite a remarkable number. But if you actually break down from store address to receipt number, to the line item details, to the description, amounts, there's just an incredible richness about receipts. And it's quite impressive how much data you can actually find. And on top of being extremely dense with over 150 data points, receipts are very heterogeneous. So now that you're kind of initiated in the arts, if you take a look, into receipts from different stores, if you look from a receipt from Costco, Best Buy, Target, any store that you go to, you can see that, yes, as a user, is very simple to see and understand the data, but the variety is quite impressive. So you can see that there are receipts that the line items are like to one side, to the other side, they have item number, they don't have item number. We also know that receipts have quite a bit of sensitive information. So such as was highlighted here, there's a bunch of data, and it is clear that there are quite a lot of things that are very sensitive, not only in what you bought, but also information such as address of the user, especially if you go to an e-commerce receipt. And so when we built our system, we knew these things. We were tackling a market that had very complex, very varied sense of data, as well as we were starting to work with banks, which meant that compliance was key. So we needed to be able to prove that where data was going to be saved in a very specific way, that we're going to have all the compliance that necessary to work with somebody big. So the way that we started was that, again, Sensible is already, we're live for over 6 years. So we built an ML-based engine. We knew that we had to support multiple formats and multiple languages. So because we're a Canadian company, we have Quebec, so we had to speak, at least our receipt engine had to be able to read receipts in English or French. Because there was that variety of receipts, any rules-based approach wouldn't work. So we used LSTM, and we just had a large set of manually annotated receipts to actually get there. And again, because it was 6 years ago, none of the big banks actually trusted AWS. And when we talk clouds, and we are cloud native per se, the only cloud acceptable by the majority of our clients was actually IBM, which is how we came to be, and how the system actually went live. So this is pretty much our Sensible V1 and how we started to be. So when you talk about things that we learned during that journey, so a few things. So it's super hard to understand how a model is really performing. So something that became very clear is that we were able to build an LSTM-based model that got F1 very high. And yet, in real day usage, it was actually quite challenging to see, well, yeah, but it's not working here and there. So machine learning models are not notably opaque. And when we're talking about understanding a receipt understanding a document that is as complex as a receipt, it was very easy to see that the results were underwhelming in quite a few cases, but it was hard for us to understand how to fix it. So what we started to do early on was actually to build something that we call EVC, which is engine version comparison, that we can actually do a breakdown of all the fields, and we can actually see how different versions of the engine compare. So whenever training a new model, we're able to see not only that the F1 score is getting better or perhaps even getting worse, but the overall F1 can be tailored to actually meet to the fields that we actually care more about. And that is another lesson we learned quite early about the number of fields. So receipts has 151 fields, and product being product, the first thing that we were asked for, cool, we want to read every single one of these fields, and then we want to do everything with them. And that was I saw Matthew's question. I'll get it back in a second. So that was the first thing that we had to go back to product, which was, hey, we actually have to figure out which fields we really care about. So how are we going to use this data was actually something that we had to understand from the beginning, and start to look into specificity around which of the fields matter. Do we care about line item name? So if you go back a couple of pages, if the data is super complex, yes, receipt date is very clearly something important. The item name is super important. But then when you go down to description, those are things that we can lower the usage, or lower the rate when we're actually measuring. So that was an interesting thing, that it was clear that it had to go back to product to prioritize, because it's very easy to say, I care about everything, but being able to go back and focusing into things that truly had more value added was very interesting. For Matthew, what models do you use to identify the fields of the receipt? So we actually built an LSTM. So the way that our pipeline works is that we actually have, in the beginning of our pipeline, we have an OCR engine, and we leverage today quite a few different OCR engines. And the results of those, the results of that OCR are actually fed into an LSTM. And that LSTM is actually what we actually use to drive to classify every token. So technically, from a flow perspective, first we classify line items, and we say this line item, we classify the lines of the receipt. And so you can see that this type is a header. And once we have the headers, we have the items. And so we classify that. And the second pass, we actually say, cool, for the items, this is the item name, the item price. So we just have a two-step with LSTMs. We don't, we started to study mask RCNN more to actually try to do image processing. So before we got there, to clean up the results of the receipt before it's fed into the OCR. Because most OCR engines are actually built for flatbed scanners, so it kind of assumes that the text is straight. And so we use our CNNs to actually straighten that up, kind of remove background and etc. But once we do that, the OCR already does the detection of the characters and etc.
All right, thanks.
Yes. So I'll go back, Kyle. I saw your question. I'll answer that in 2 pages. So the second thing that another thing that we learned was that DevOps is very, very, very expensive. So the first intuition of developers, yep, we can actually create something quick. It's very quick to start a Kubernetes stack from scratch and to just have the services development. But building software is cheap, maintaining is very expensive. So as soon as we were able contractually to move away from IBM, and there was actually quite a few surveys recently on most dreaded technologies, and IBM was, I think, #2 after WordPress. It was just a nightmare. We had so many issues, and it was a blessing when we were able to finally migrate over to AWS. And we were finally able to actually start leveraging more of the managed service. So definitely something that, as part of our journey, yes, it's clear today, but like there's always the question that an EC2 instance is very cheap. So just starting with your own hosted service is cheap, but investing in something like a SageMaker, investing in the queue management built and maintained by AWS makes a world of difference in the team's capacity. So there was definitely something that we learned and were able to get. So as on part of our journey to actually get data. So we just started with, we have images, and again, images are the most popular field. You were able to get from images to actually get the data and structure it. Once we have that structured data, the next step that we had was we need to be able to enrich the data. And that goes to Kyle's question, which is, once we actually are able to structure, and all that our receipt engine really is doing is saying line item 1, it is the text APPLE. But from Apple to actually understanding that there's a fruit or maybe there's a phone, it's actually super tricky. So once we have that, we have to do what's called data enrichment, and that's the question that Dhruv is answering. This is very tricky from a flow perspective, because effectively what we have to do is that we had to build a very large catalog. And based on that very large catalog and a lot of techniques in terms of enrichment, we're actually able to get a proper classification of every single line item. And based on that classification, we can actually start understanding. So yes, Walmart really abbreviates. They also luckily actually have a UPC next to the product code, but the behavior of every single merchant is different. So Best Buy would have an UPC, Walmart would have an UPC, Costco, I believe, have an SKU. And so there is a specificity on how every single merchant actually is able to extract it. And what we did was actually have that 2-step process in which the first step, the goal is just to structure the data, understanding clearly what is a line item, what is not. And the second step is actually to do that understanding and unpack and try to attach everything to a product catalog so that we can actually have a proper classification. And that was one of the big problems that is necessary for us to actually derive all those insights. Once we were able to get out of LCTM's pure and try to go to transform models, something that again on our system, because it has a real time component, people take a picture of a receipt and they expect to get the results right away or within a couple of seconds. It's very interesting to see how much transformers models are a lot easier to train, but they are a lot heavier to run. So all those benchmarking and performance testing and that tuning is actually super key and was necessary for us to keep our quality of service. Another part on that was actually a big learning from us from a business perspective that was that for the longest time, we had a machine learning team and we're kind of expecting them to do both parts. And so to both structure the data as well as enrich it, as well as actually understand from Apple to actually what the SKU is and what that product actually is, was that we were just expecting one team to finish the engine and then continue. But overall, because receipts vary so much, because there's so much data drift, the merchants can vary models because we have more data into our system today than we had in the past. And because of that, there's more variety. Something that we had to learn, like it took us a long time to say, you know what, like those are actually two independent problems. And unless we have two separate teams that are dedicated to solve every one of these problems, we will not get to it. So what allowed us to actually start actually understanding the receipts was this understanding, is that yes, Google has the best search engine in the world, and I guarantee that the size of the team that maintains Google search today is bigger than it was 5 years ago, because even if they are already the best on that, the goalpost keeps moving around. And so it's important to keep your team staffed and making sure that the team is always working on that. And that's how we actually were able to start both understanding how the engine works and enriching the data and having that separate missions in terms of teams. Kyle, did I answer your question?
Yeah, that was great. Thanks.
Okay, Rick? Okay, I don't know if there was a question there, but any other questions on this path? All right, so from a flow perspective, once we actually were able to do these two steps, that's when we're actually able to derive user insights. So from the first level, which is receipt engine and data enrichment, now that we're actually able to understand what is on everybody's financial document, we're actually able to build user insights out of that. And out of those user insights, the way that we can compose them is by saying, well, we can see that most of Daniel's receipts are groceries, yes, but within groceries, these are the types of groceries that he buys. And therefore, we can actually start building features at the user level. And those features can actually build those insights. So I had a question earlier, I think it was Matthews, on how we were able to guarantee how the banks would actually do this. So one of the key things for us is that because we serve large financial institutions and we serve Chase, again, our prime example, Chase doesn't want Sensible to really tell them that Daniel likes sports or that Daniel is a new parent or a new homeowner. What Chase is trying to do is for us to actually give them features that are meaningful to, on their side. So what we're actually doing at the user insight level is that we're building user features that have a lot of explainability to them. And that is how somebody like Chase is actually using the data. They actually are able to understand, based on the features of this user store, we can actually see and enrich with their own data. Because it's important to say that Sensible only has a part of this data. We don't have the full user profile. Because all that we said here from the get-go is that Sensible has receipts. But receipts have, again, whatever receipts have. From a user flow perspective, when Chase creates a user within our system, or any bank for that matter, we don't know that the person is. We don't have demographic information. We don't have contact information. Sensible is just a processor of that data, and we have to feed that data back into the banking system. So the way that our system operates is that we can actually leverage all the receipt data to enrich the business profile within the clients. And now our banks can actually have a more detailed profile and more detailed personas that can then be triggered. So as part of that journey, again, something super important to us was to figure out what has to be real time and what can wait. So from an end user perspective, when you're taking a picture of the receipt, very clearly that has to be a real time processing. We had to be able to give a quick feedback on whether or not did you get a good picture, was able to read your receipt and to actually understand if this receipt was a grocery or what was there. But when we're talking about what can you do with this data, those are not necessarily real-time needs. And so this was also an important lesson for us on this journey, was figuring out which of our data points actually needed to be real-time versus which of the ones that could wait for a slower processing time, that could wait an hour a day. And so having that split was actually a very interesting separation of concerns that helped on our data pipeline overall. Also important to know is really focus. So something that we've been getting a lot better at is when we're trying to derive user insights is to actually understand based on which are the insights that we're trying to generate, which are the features that we have to understand. So on Kyle's questions earlier on how do we actually unpack, that is also important. We have to understand, depending on the user insights that we're trying to derive, we're going to try to spend more energy enriching receipts from a certain type of merchant or from a certain type of catalog. If all that we're doing is getting grocery receipts, then Sensible probably should be an expert in everything related to grocery, everything related to food. And based on that, we should be able to have a catalog that's very rich on that. But if most of our data is actually coming from, if we're trying to generate insights that are associated to electronics, then that's what we should do the catalog. So having that end user that end utility visibility is key because it allows us to focus on the part of our pipeline that are relevant. We could probably spend years only at the data enrichment level because again, it's super complex problem. There's a huge variety and there's hundreds and hundreds of ways to display the data and merchants can choose to change that any day. So figuring out how good is good enough was actually a super important part. And again, the last part was pretty much how do FIs leverage this data. So if we're serving a small community bank, they need data that is a lot more tailored and a lot more detailed because they won't have a data science team to actually consume this data versus a large FI that could actually get a data science team to just get more feature level data. So that's also something important from a B2B perspective, understanding if the consumer of your data is going to have a data science capability or not. So again, something that we had to spend a lot of energy understanding.
Question.
Yes.
When you, well, that was appropriate. When people are taking pictures of their receipts, how do they take a picture of a long receipt, maybe from CVS or just they're doing a grocery shop for a large family, so they always are going to have a pretty long receipt. Do they take multiple images? Do they do a video and scan down the receipt? What's generally worked best for your users and for your receipt engine?
So that's a great question. And yes, to Kelsey's point, we can't. So first, you won't be able to see, but I have a receipt here on my phone that is a grocery receipt. It's quite large, and you take a picture from far away. So modern phones are quite impressive in terms of the resolution. And in all honesty, you have, yes, CVS receipts are case apart, and they are famous for that, for being non-eco-friendly receipts. So for a CVS receipt, you likely have to take a couple of pictures, and then you can always attach. So yes, you could take a couple of pictures, and then we'll just combine on our engine. But once we actually, but again, for most receipts, just a picture from far away is usually sufficient, usually high enough resolution to able to get the data. But yeah, it's definitely a common problem on a few merchants, but it's more merchant specific. The other thing is that for CVS receipts, mainly the information that the user would care about is that, well, sure, you bought some, a CVS receipt is mostly a grocery store in practice. Typically, the information that you really care about is typically in the beginning of the receipt, because that tail end is promotions and coupons and etc. And that utility is more reduced. So yeah, those are the two questions, but yes, you could have more. So for Matt, the question is how much is open source? So most of our backbone is built on, well, all the API is built on Node.js with Mongo. Most of our stuff is built over, I would say that we started as purely open source. But once we actually got to more managed things, we privilege services that are managed, but they are typically, we build things in a way that we could move to a pure open source if we had to. So if we choose to use for something like DocumentDB, yes, it's pretty much a managed version of Mongo. And we could always move back to Mongo. So today, our direction is mostly to go to managed service. Yeah, but like again, all the AWS tools are proprietary, but they really are Apache Foundation tools, and they just do they typically freeze a version and just use that. So yeah, AWS Glue really is yeah, it's just another Apache tool that is leveraged. So for AWS Glue, we have to fix the version of Spark, and then you can do it. So I would say that our stack is mainly today on managed tools, but they are movable with a little bit of effort. Choose something managed, choose something open source if we want to.
Thanks.
My pleasure. For Ron, what types of data will be added during data enrichment process? So what we're really trying to do at the data enrichment is to link, so our ideal status, we're never going to be on ideal for everything, but on the ideal status is based on a receipt, you can link every single line item to a specific product catalog. So you can actually link from a line item. So on my example, I bought mangoes. Ideally, I have an SKU link to mango on my catalog that I know the price of the price of how much I paid. I actually attach to a brand if a brand exists and all of those things. So ideally, we can enrich for everything there. It's not going to be there, so we have to default to a lesser state in lots of cases. But when we talk about data enrichment, is mainly linking every single line item to a product catalog. So from Johnson is based on, so can we assign can we actually understand and offer people suggestion on how to manage their money better? And again, that goes back to a big utility that banks are looking from our tool is that if we actually are able to understand at the catalog level and at the SKU level, so if I know exactly that you bought Heinz ketchup at this size, I can actually make we can actually understand where would your basket be better spent. So on my example of my receipt, I bought, I don't know, probably 30 or 40 items in my grocery store, and that's the list here. One utility that Sensible could offer is looking into my list of grocery store, saying, well, actually, had you been to Costco, you have saved money like this. So those are ways that the banks are trying to get utility to the user by suggesting them, hey, if you want to save money, change grocery store. If you want to save money, buy this item in bulk. Those are examples where we can actually help users. So based on, so I'm kind of giving a conditional answer is if we were able to correctly map what you bought to something on our catalog, then yes. Then the question is how much of that each receipt we're actually able to get to a catalog. But assuming that we got, then yes. Then we can't say that you should have bought ketchup at Costco because it's cheaper, but because you buy in bulk. And 100% that Costco is a trap. I can tell you that the ketchup is cheaper, but everything else that you buy is not. Any other questions? So thank you so much for everybody's questions. I would not have been able to speak for an hour if I did not have everybody just interacting and asking all about our stuff. How important is Python to your stack? Our historical stack is mainly based on Node, but everything new is based on Python. So I would say it's very important. So every new thing that we put up is based on something Python. So our developers, that's essentially where they are today, mainly moving away from TypeScript over Python for most new things. Cool. So yeah, I can send a link anyway, if anybody wants to reach me, I'm sure there's my email somewhere. So feel free to send me any questions or ask anything else that I have failed to answer. I'll stop sharing.
Awesome. Thank you so much, Daniel.
Thank you.
That was a great presentation, and my apologies for the naming mistake. I've corrected the slides.
All good.
Cool. I think Preethiviraj has joined. Let's see. Cool. Great. Preethiviraj, are you ready?
Yeah.
Cool.
You guys able to hear me?
Yes. So just a quick intro, Preethiviraj currently researches machine reading and has been working in the intelligent document understanding space for the last 3 years. He's the author of 3 different libraries, Grandformer, Styleformer, and Parrot Paraphraser. In the past, he's built large-scale distributed data systems and works in the technology, behavioral economics, and psychology fields. And today he'll be talking about building a grammar error corrector. Go ahead.
Okay. Okay. Hi. Hey. Am I audible?
Yeah, we can hear you.
Yeah. Hey, thanks. Thanks for this wonderful opportunity. Thanks for having me. And let me go ahead and I'm sharing is disabled.
Bottom center of the screen.
No, I think Mac is. Give me a moment here. Yeah. Okay.
I see a slide.
Yeah. Okay. It should be in the full screen mode, and let me know if you guys see it. Okay, so that's the topic. The idea is to tackle grammar errors, but you can solve the same problem multiple ways. We're just gonna spend the next 45 minutes or so to discuss how we solve the grammar error corrections in written text, whether it's going to be human written text or it's going to be system generated text by mining data from emergent systems. Because why emergent system? Why not conventional ways? Some of the things we're going to talk about. I'm going to quickly, thanks for the introduction, Aarti, but this is me. A couple of decades of applied research. I've done some time in NLP, and data engineering is one thing. And one of the things that I'm really enjoying doing, especially the last couple of years, is how to put together creative data sets, especially in tandem with machine writing. That's one of the things I'm trying to do, and that's one of that's the crux of the talk today. How do you put together creative data sets for the tasks, especially the tasks which are very data hungry, and so let's dive in. And in terms of the target audience, you get the best return on investment for your time if you are acquainted with language modeling, a little bit of sequence modeling. I will try to make it accessible for all the audience as much as possible, but if you do have some basics and background, it'll be a lot more easier, and it'll cross over a lot more easier. Just thought I'll share that. So this is what we're going to look at. It's a very simple agenda. It's not we have only a couple of things to go over. We'll look at the anatomy of a grammar error task, because there's a lot of misconception as to what actually the task itself entails, especially due to the arrival of large language models nowadays. And I think my system is slowing down. I'm gonna just turn on the camera. Yeah. So we're gonna look at how what are the different ways we're gonna collect the data. There is conventional ways to do it. There are unconventional ways to do it. And then we can have a look at it, how I collected the data. First, look at the data, what it looks like, what is the actual data distribution looks like, stuff like that. And then we can do a quick walkthrough of the code as to how the whole data generation process looks like. And then we can look like where we can go from here, right? So that's the high-level agenda. Oops, I'm sorry. Hello.
Yep.
You guys are able to see?
Yeah.
You guys are able to see the screen?
Yes.
Yes.
Yeah. So here is here is the takeaway for you guys. How do you get endless supply of community annotated, unbiased, high quality data cross domains, possibly for multiple languages for free? I understand this sounds like a stretch and it sounds like too good to be true. And if you will indulge me, I'll take the best shot in convincing you that this is possible. So please hang on for the next 40 minutes and you be the judge of it at the end of the session, if it's viable or not. So let's jump in right away and look at the anatomy of the grammar correction task. Right, for a language, I mean, grammar obviously is a very language specific construct, and it is the canonical, it's a canonical construct of a language, and it is very specific to language. And as per the linguists, especially you guys have to probably look him up, Christopher Bryant. He has done a lot of work in putting tools together for grammar correction. And as per this definition, broadly, that these are the 25 categories of errors English as a language can have, across competencies. When I say competency, the proficiency of the language, you could be a native speaker, you could be a beginner. This 25 categories of error should probably, I don't know if I can call it 100% of all the errors will be covered in this 25, but a solid 95 or more percentage of errors will be covered under this categories of error, which we will discuss in detail. So don't worry about the details, but I just want to put things in perspective, saying that it's just not single errors. If you just take, for instance, just the verbs alone, there is a bunch of verb related errors, there's a bunch of noun related errors, and then obviously orthographic errors, word order errors. There's some of them are critical, some of them are really important to make the language look palatable, some of them are not so important. We'll look at it in terms of human writing and machine writing, what are more relevant, what are more important in a moment. But to motivate and to set things in perspective, I just want to talk about the problem statement itself. So this being the anatomy of grammar error correction, what makes grammar error correction actually a higher order task when compared to other natural language tasks, if you will, right? So one of the things is the linguistic nuances, as you can see, right? So all the perfect verbs like creaked, creaked, those kind of perfect verbs goes in a regular way. But if you take certain exceptions like sneak, sometimes there is an argument. You can look it up. You can read. People argue sneaked is fine, and some people say snuck is the actual past tense. And there is an article returned to Grammarly as what is the actual past tense for sneak, right? And then there is domain nuances. If you will, in a culinary world, spaghetti and meatballs, just because it has got an and as a conjugation between the two words does not make it as a plural. It's a singular entree. So domain nuances actually define the grammar, surprisingly. And also there is a huge factor, which is the linguistic variances across the languages. The recent paper from Stanford, which basically calls all the pre-trained language models as foundational models. And I encourage you all to look it up and spend some time, at least in the language part, to understand what exactly I'm saying by linguistic variances here. So the language is huge in terms of what even the largest foundation model can solve today. We'll talk about it a little more. In a little. But before that, you can look at the example. Like for instance, if you take Thai, that's probably on the simpler side. It does not even have a concept of subject-verb agreement. The verbs don't inflect. There is no is and are. There are no tense and things like that. But if you look at the other side of the spectrum, Dravidian languages have a lot more complex rules than what you saw as 25 rules in English. So this is, the linguistic nuances inside a single language and the linguistic variances across the languages and the idiosyncrasies basically make it a higher order task. We will also look at what I exactly mean by a higher order task in a moment. Just hang on with me. So what makes so given that context, given the complexities, given the fact that it's a higher order task in the 25 different categories for English, and then what exactly what makes a good grammar error corrector, right? For a given language, a model that is trained to understand all the specific errors. When I say all specific errors, is the categories of errors and the variances, the instances of the errors and the nuances, plus offering a comprehensive coverage of all possible errors in terms of volumes and varieties. Sometimes that's the problem because some models tend to correct grammar errors. Sometimes they have a coverage problem. Sometimes they do cover all kinds of errors, but they do have a nuance problem. Certain instances of certain types of errors they don't tend to correct. And then understand the severity of errors, because obviously a subject-verb agreement is a lot more severe compared to an orthographical error or a simple change in the noun, or an apostrophe is a lot more, a wrong usage of an apostrophe in a plural noun is a lot more severe than a morphological error, right? And then optionally offer highlighting the error and possible edits and stuff like that. So this is giving you kind of a structure for what exactly we have looked forward in a good grammar corrector, right? Given all that, so what is the data strategy, right? Looks like we have established the fact that this is just not needing it. This does not need a lot of data, but it's going to look like a lot of nuanced data covering a lot of different variances. So there are a couple of different ways we can look at it. The conventional wisdom is, you can put together a team of dedicated language experts who write the critical mass of realistic grammar errors, manually understanding the whole litany of errors, take each error and then write the errors, and then validate the error type by coverage. Because if you look at Christopher Bryant or anybody who wrote in the past, the paper that I referred in the past when I showed the 25 errors, apparently the type of errors made by experts, the native speakers, as well as people who have bilingual proficiency, as well as people who are novice, obviously varies in terms of both distribution and kind of errors and the way in which they make the errors. So if you want to make a really good grammar error corrector, you cannot afford to have a bias towards only the errors the experts will make or only the type of errors the experts will make. So you want to have an equal distribution of kinds of errors made across the proficiency of the language. And also you want to make sure that the quality of the data, because if you are going to, when you're writing the data set, if you're going to have any unintended human errors, which is possible whenever humans are involved in putting data together, obviously they are prone to errors. If you're going to have some issues in the golden data, you are bound to run into issues. So you can do this. This is one way of approaching it. As you can obviously see, it's resource prone, it's error prone, and it's expensive to get this done. And then there is no way you can escape. I mean, you just have to add people. You just have to get linguistic experts to do that. One possible alternate is you just have a set of language experts per language who are just going to moderate the whole process. And then like Amazon Mechanical Turks, some kind of crowdsourced data generation can happen. I'm just spitballing here on the point. I'm not sure how much effective it's going to be, but these are the conventional ways to put data together. Or There are, people might argue, I have a language model which can generate data. I can come up with some creative ways to generate data possible, but we're going to look at it, why different ways of doing, why those are all either expensive or expensive and error prone in a moment. So this is the conventional wisdom, and then what probably can be a unconventional way of putting data together. That's what we're trying to see here. That's probably the crux of the talk. So for looking at the unconventional wisdom or unconventional ways of looking putting data together for grammar correction, we're gonna look at a couple of different trends. So it probably is gonna look like a little bit of a detour. I promise to circle back and tie it all back together. The first trend that you want to look at is the emergence. We all understand what an emergent system is, right? The whole is greater than some of the parts. Like, the brain cells individually are the brain together is a lot more valuable than the individual brain cells, and same goes with ant colonies and beehives. So if you look at one of the important emergent systems of our time is how we define truth today. Wikipedia has become synonymous for defining truth, and the way the knowledge has been created, distributed, and consumed, it has changed a lot, especially with Wikipedia and web. Now things are moving from distributed to decentralized as we speak with blockchain and stuff. So there has been so Wikipedia obviously is greater than knowledge created by a closed group of experts. And if you look at the trend, it is community generated content edited and by volunteer editors, who are having oversight editors. When I say volunteers, they're coming from different domains, different language expertise, and it goes through a consensus process. They do it multiple times, and to make sure that the quality is good. And I encourage you guys to look at the Wikipedia entry on reliability of Wikipedia. When I say reliability, I'm not just talking about quality, I'm also talking about the veracity. There is also vandalizing in Wikipedia, but still for our context, the vandalizing as well as the fake information in Wikipedia is not relevant. We are only talking about the quality of the iterations the editors take to make sure that the data is of high quality. Nature has compared the quality in 2005 to say it's pretty reliable. They gave something around 90-95% it's reliable in terms of veracity as well, which is not relevant for our conversation. We're talking about quality, but I'm just putting it out there. And it was so good. Encyclopedia Britannica physical copies have been seized. So this is one of the trends I want you guys to ruminate about and think about. So we have wealth of knowledge in electronic form available for us, and how it's going to tie back to us, we'll look at it in a moment. And the next thing is, first is emergent system, and next trend we want to look at is reframing problems. I probably want to give a trigger alert. The intention was not to be gross or anything, but this is a really powerful example of reframing, which I'm going to show. But if you guys can possibly think about some of the powerful reframings of our time, which is basically solving hard problems by simply reframing the problem statements, basically bending the problem as opposed to rolling your sleeves and moving head on with the problem, right? So I just want to stop and ask a question probably to the audience to think about it. This is one of the biggest problems and expensive, probably might not think about it. If you guys can take a moment and, indulge me, what do you guys think probably the cheapest and most effective way to keep the airport urinals clean? If anybody want to take a shot at it, you can. Otherwise, I will give the answer and we can move on. I guess.
How about the fly model?
Yeah, okay. So you know that. Okay, all right. So for the folks who did not know, the answers usually will be, ranging from changing the structure, coming up with structural changes, changing with the human habits and stuff like that, right? Giving training and then make sure that there's a lot of people. So ranging from changing the structure of the urinals itself, the parcel in itself, and all the way to changing the human behavior. There are different kinds of convincing wisdoms coming in, but one guy thought it can be solved differently. I don't know how many of you are aware of it. He came up with a structure. He came up with a sticker, which he just wanted to put it there. And then this is for men. And the explanation was pretty simple. This is what he has to say about his class. The young guy, he just said, you know, as much as it is very insulting and demeaning to the guys, but this is what he said. Guys are simple-minded, and you know, if you want to you know, change or distract them, just put something there and they'll aim for it, right? So again, I'm not trying to be gross. I think it's a very powerful reframing. It's a patented solution, and it's across multiple airports, so it's saving a ton of money for a lot of people. So why this reframing, right? So if you look at, it's very relevant for us. If you look at our deep learning revolution in data, we have multiple different paradigms to circumvent the lack of availability of high quality labeled data, right? So in terms of labeling paradigms, people came up with, hey, I'm gonna come up with a distance supervision or a weak supervision, and then I'm gonna derive a better model from out of that. And then people came up with pseudo labeling with feed models. And then in terms of learning paradigms, you know, they have invented end-shot learning, which is sample efficient, and then self-supervised technique where label data is not required, and then generating more data. So if you look at different paradigms, we have, you know, somehow we have convinced that we could work around, or we can go around the fact that there are no high quality labeled data, right? But that's not the case. I mean, I'm sure everybody here would agree that given high quality data, we probably will all choose to go for supervised learning than something else, because it has a proven track record and really works well, especially with complex model architectures. If you throw in a lot of data, the performance is gonna, you know, increase tremendously, in spite of all these innovations in fighting the lack of data, right? And I'm not, this isn't a far cry by any means of imagination, any stretch of imagination, because even the big boys, you know, the big tech companies are doing it. People might know, if you guys did not know already, these are a couple of examples of powerful reframing. I believe everybody know the concept of reCAPTCHA, and Google is trying to understand the proof of human verification. In some of their sites, even in their search, they bring the reCAPTCHA, which is on the left-hand side. They basically ask you to prove yourself that you're a human by choosing specific images, but actually you're labeling data for them indirectly. So that's one of the reframings. And Duolingo is a global translation platform. And every time you learn language and you take tests and, you know, translate, you know, to test yourself by translating sentences, they take those pairs, really use those as labeled data. So these are a couple of different powerful reframings which are in production, which are at large scale, which is making a lot of sense even for large tech companies. So I'm here to argue or try to convince you that rather than going this way to work around the lack of data, how about reframing, you know, one of the existing techniques and blend the problem slightly to our advantage and solve the problem from there. So how this reframing, you know, I'm trying to tie the idea of emergence and the reframing together in a single thing. So the idea is to repurpose. A flavor of reframing is repurpose, which is what we're going to do. So here's my proposal, and this is not my thought process. Like I said, this is I'm simply borrowing research and standing on top of the giants. Like there is again, I encourage you guys to look at the papers linked at the bottom of the slide when I shared. There has been a hypothesis around quite some time to look at the Wikipedia edits, right? So why can't we repurpose the before and after versions of the Wikipedia revision history? So let's pause the presentation here and look at Wikipedia, for instance. So if you look at a typical Wikipedia page, there is a version history, and I'm not sure how many of you had the chance to go look into it. And there is a before and after version, and people do all kinds of revisions, right? So So if you can see, there are multiple different reasons: factual inaccuracy, there is rephrasing, there is stylistic changes and grammar errors and stuff like that. So there are a ton of grammar errors which are getting fixed as a part of the community-based edits that is happening. So the idea is to leverage the Wikipedia edits, the revision history, to harvest the grammar errors from those edits and frame grammar error correction as a translation task from incorrect sentence to correct sentence, given the rise of natural language generation models. Can we do that? So that's the proposition here, and this isn't, like I said, this isn't my idea. There are a bunch of different researchers, and they're trying to prove this hypothesis, and I'm just taking it and trying to run away with this. So yeah, to tie it back together. So the before edit that is the text with the grammar error, which is going to be your left-hand side of the text-to-text generation task, and the right-hand side is your after edit, which is the grammar error fixed by the community. And but the challenge is there is going to be a lot of different edits. How are we going to come up with a nice pipeline which is going to look at these edits, harvest the grammar errors, and then tag it based on the error types, and then train a model? So that those are the things that we're going to look at it. But at a high level, that's at a high level. If you look at it, yes, Wikipedia has got a community annotated data, which is unbiased because it goes through multiple iterations, and they try to maintain the quality. And Wikipedia is available in multiple languages, and yes, they do grammar correction. Hence the proposition. Multiple languages, it's in red, and I'll tell you why it's in red. But you don't really have to spend a lot of time, as we saw in the conventional wisdom slide, where we probably have to engage language experts and validate the data manually, and then we have to see the spread of the data, and then we have to see the competency, because the proficiency of the language across the community is going to be a little different, because it is highly unlikely we're going to have bias. I'm not saying we won't have a bias, but the likelihood of having a bias is relatively less, right? So this is the money slide. This is what I wanted to mainly pitch, and this is the thought process. And based on this idea, I built a model, harvested some data from Wikipedia edits, and then harvested the data, cleansed it, and built a model, and it's performing reasonably well given the budget of the hardware and stuff. But like I said, let's look at it. Let's look at the data, and I hope x-axis is visible. The y is pure, it's a histogram of all the errors. This is just a couple of 100,000 records, and if you can see, after I filtered out all the non-grammatical edits from Wikipedia revision history, and I was able to, for a couple of 100 records, there's a pretty good distribution. Pretty good volume and variety in terms of the kind of errors. These are the 25 kind of errors, 25 or 20 odd errors we saw in the beginning. As you can see, there are different varieties, and then the count is obviously the count of errors is obviously a little different because of if you really, I always wondered, if you put a distribution, not all errors are equally made. There is going to be, that people are going to make more spelling mistakes compared to orthographical errors or word order errors, and then there is punctuation issues. When I harvest the data, this is what it looked like. And then it's an expensive process, and I'll explain why it's expensive, because the ratio is typically 3:1. Like if I filtered, if I took 600K data and filtered it, I arrived at around 250, 300K. So it's only roughly 50% of data is useful from the Wikipedia edits as grammar data, right? So there was also some synthetic corruption available as a part of the C4 released by Google. Just for perspective, I also tried to take it and blend it and see, like, as you can see, there is a little bit of change when I move away from when I blend the Wikipedia grammar data along with the C4 corruptions. And so this is how it looked like. So did it work? Did it actually, using that data, did it actually turn out to be a grammar error corrector? Was it able to recognize errors? Yes, it was. And but given the budget, so the model that is available in Hugging Face right now for you guys to try. It roughly had 650, 80% wiki edit data. The compute budget is, a single GPU of 16 gigabyte, and the pre-trained model is not so big. So given the budget, the model is imperfect, but definitely good. It picks up, for an untrained, compared to untrained language models, it definitely picks up grammar errors pretty decently. Do try it out. So there are a couple of words of cautions on the synthetic C4 data on top of the Wikidata. I mean, why not just Wikipedia alone? Why combine C4? That's obviously it's a compute expensive to filter Wikipedia data, hence I combined it. But there are some blind spots in using C4 corruptions. I will circle back to that in a moment. Please remind me if I miss it out. But before that, we will quickly look at a walkthrough of what we were discussing in terms of data. But I would, if you guys have any questions as of now, I can pause and take questions if you have any questions so far. I guess not.
We have one question in the chat.
Yeah, I'm just looking at it.
Do you model how language change over time?
Do you model how languages changes over time? Correct grammar has changed significantly since. Okay, so as you can see, the language variance. For instance, any kind of antique language usage obviously is not going to be part of Wikipedia. Wikipedia is contemporaneous, and what is available in the vernacular and what is available in terms of vocabulary, in terms of the current lexicon, is what the users are going to use. And by pure happenstance, if we had any ancient writers who had ancient styles of linguistic experts who brings that arcane usage, well, we are in luck. Otherwise, there is no intent to bring in arcane usages or things which are a little ancient. We are not. That is not possible with the proposition I have in place. Yes, and I don't think I can also confidently say even the teams who are building language corrections. I don't want to name names. You guys can imagine who are solving these problems. You probably can't hire linguistic experts who are still having the arcane knowledge of the antique language usage in terms of words, vocabulary, and things in lexicon and vernacular. So that's my answer, which is pretty much the grammar model is going to be acquainted with the contemporaneous uses of the language. Does that make sense? Or is that the answer you're expecting, or is there something else I'm missing? Okay. Shall we move on? Can you provide some examples of tokenized? Okay, but evolution hasn't stopped. Someday we might want to proofread emoji usage. Oh yeah, sure. Yeah, okay. So emoji usage. So I'm gonna make a demarcation. The evolution is not stopped, and it is not gonna likely stop. But the line here is Wikipedia is the professional usage. So there is obviously there is the professional version of the language when I say contemporaneous language, and there is always a casual use of language. Correct me if I'm wrong. Emojis are not part of your professional language, and the grammar error corrector, which I'm proposing, as well as people who are proposing, are not necessarily proposing it for casual usage. Even the best grammar error corrector available in the market is not doing a non-textual correction. It basically make sure that the text is in the tone of the text and make sure that the grammar errors are corrected, not necessarily proofreading emojis. But I take your point. We probably have to get into the world of emoji error correction, but for casual usage. But then again, I would argue differently. Our casual users who are doing texting and stuff with emojis, do they really care about grammar error correction? I'm not really sure who's going to proofread their casual text messages. The target users for grammar error correction today in the humans are content creators, journalists, reporters, authors, poets, people who, students, or people who write papers, term papers, dissertations, where the language is in the professional context and it has to be of utmost quality. But then again, I take your point. We probably have to, and I don't have a good answer. How am I going to get the emoji-based casual text? So, I mean, we could definitely look at harvesting data from a casual forum like Reddit or something else, Reddit comments and something else, and definitely we can look at it. But for the scope of this conversation, I definitely did not look at it outside of the professional context. Hope that answers that question. Is there a question we skipped? There is another question. It says step 3, can you provide examples? Can I move on with the question from Ron, or is Johnson is okay with the answer? Do you have a follow-up, Johnson? Okay, all right. Can you provide the examples of tokenized? Okay, here what I mean by tokenized is, okay, before getting into the example, I just want to say that the pipeline, the customized pipeline that I used for the purpose of this conversation, the model that I built is get a Wikipedia revision histories are available. And if you guys are not, aware of the fact that what are the machine readable wiki revisions or wiki edits available, I have put in a slide here. I'll talk about it for a minute and then go back to that pipeline. So there is a bunch of different versions. When I say machine readable, you can write simple parsers to take the data, the before and after version of it. So I will share this, and you can have a look at it. The most interesting thing is the last one, the whole Wikipedia history in the form of HTML. It's a AAA paper. You guys can pick and choose which one suits you the best. So there are a bunch of different machine readable versions. So coming back to that, so the first step is obviously to pick machine readable wiki revision history of your particular domain. And like we spoke about the domain nuances 15 minutes ago, that the culinary domain has got certain nuances as to what is singular and what is plural. It dictates the grammar. So if you are trying to build a grammar character for a particular domain, Wikipedia has got different domains. You can pick and choose a particular domain. Then obviously a language. So I'm going to stick to English for the context of this talk. So the first step is to obviously take that format, whichever format it is. The wiki text is a canonical format they use. That is their markup language. The example that I used, I'm gonna show how it looks like. And so convert that into pairs and then frame it as a translation task. So that we want to convert that. Then optionally you want to deduplicate it, because there's a Wikipedia is going to have a multi-turn edits. What do I mean by that is there are going to be multiple records of the same things edited for multiple different reasons. If you want to deduplicate it, you can, or if you want to keep it, you can keep it. So that's an optional thing. And tokenize, when I say tokenize, I'm not really talking about a full-on natural language tokenizer like a word piece or a sentence piece or some kind of tokenization. So the tokenization we are talking about is, I think it's a. Can I circle back to that question in a moment, if it is all right? Because I will show you in the notebook, in the code actually, or in the sample, I'll show you what I mean by tokenize. Just hang on with me for a moment here, and then optionally tokenize the data with the pairs that you have, and then you might want to filter. So here I want to introduce a tool which I use, which is called the Error Annotation Toolkit by Christopher Bryant, the guy who actually indexed. We saw the 25 errors, like this is a good thing to look at it. This is error annotation toolkit. Is an automatic grammar error annotation toolkit. How it uses a particular format to annotate errors, and it's got a command line interface as well as a Python SDK which you can use, and then you can either pass original and correct files, or you can pass individual sentences to get the output. I'm using the API version. I will show you what it can do in a moment. So circling back to the pipeline. So we got a lot of different not so useful and little useful grammar error corrected versions of original correction pairs. From that pairs, you might want to filter out, and then you get the error spread type to make sure that we don't have any blind spots in terms of error type. Like there is no science here. You just have to make sure that the volume that you have filtered out is good enough to have the coverage. Otherwise repeat your process until you have a satisfactory edit, which is pretty much like an hyperparameter search. It's not, there is no science or anything like that. You just repeat the process until you have enough spread for the kind of model you want to build, and then detokenize. And then this is the pipeline that I customized for my needs to come up with high quality grammar error paths, which are detokenized and ready for training a text-to-text generation model, right? So we spoke about the different sources, and then I can give you a quick walkthrough. I think given the context of the talk and the time we have, I just want to keep it really crisp and so the steps that I showed in the pipeline is what we're going to see, and I have the files in my Google Drive. I'm going to bring it up here, and I have written a simple script that basically takes the wiki text data that I had. And if I don't know if anybody who's for the curious souls, this is how it's going to look like. The source from which I have taken the wiki data, the wiki text is going to look something like that. And as you can see, this is one entry, an ID to contributor, which basically says, this is the machine readable version of what I showed you here, right? Like we saw this, and so like for instance, if you look at this, it's a little bit slow. So what you see here is the rendered version, right? Actually, it has been rendered as HTML. The actual markup language is the wiki text, and it's going to look, once you harvest, it's going to look something like that. So what the script that I've written is going to do is take this machine readable format, and then you can see, as you can see, these pluses and minus, pluses and addition, and then removal, what has been added, what has been changed. Entire edit is going to be available in a single entry, and the script is going to take that and then convert that data into a pair, right? So that's what's happening, converting the wiki edits data in pair in this step one. I'm just taking a single example. And if you're interested how the data would look like, if you uncompress the data, the file that you saw, the edit file is this, and each of those files, you're gonna get a lot of English wiki. So this is for English for a particular date. If you are interested, you can see this is for which date we got it from, what is the edit version, and then the size of it, it's in the form of text. And then one file is what you're seeing here. And you're going to have per domain, per page, you're going to have a bunch of files like that. You can harvest those files, and then per file, you can go and convert them. So once you do that, I have the script is basically the generate wiki edit pairs is what basically is doing is taking the file that I showed you and then converts that file into a parallel data set. Parallel data set is basically a pair, which is a pair of original corrections. And, so this is, from the data that you saw, we got pairs of data right now. And you can see that this is one example. we can look at more examples. This is just the left and right side where there is something wrong. We will see more examples. I just want to say the pair is ready. So people who are asking about tokenization, as you can see, there is a space between the comma and the actual the word. In reality, we will not have the space. But the tokenization here is the errand tool, which we are using for the errand tool we are using, which is basically going to read the text and filter it out based on grammar errors. That expects the content in the tokenized format. So the tokenization here is to, if you use any kind of pre-built tokenizer like Stanford or Spacey, it's going to basically give it split across and give it like this in this format. So that's what I meant here. That's an example of that. So once you have it, the next thing is to tag all the pairs in terms of what kind of errors a particular pair, what kind of error it is having, whether it's useful or not. How do we filter that? But before that, we'll look at what errand does. Just want to quickly ask this. Just want to quickly ask: is anybody acquainted with errand here? Has anybody done any work with errand in this group? Probably not. I'm going to take that as a no. So I'm going to show an example here. So as you can see, using errand, I've written a simple method which basically takes two sentences and it's going to create an annotator and then annotates the error and give it back. So what errand does, basically, the Python SDK version of it is take two sentences. Obviously, I have made a deliberate subject-verb agreement error and a punctuation mistake for a question, and then I give it. So basically, what you see is it can locate the error in a tokenized version, and it comes back and says, the offsets of the token which is having the problem and what exactly the problem is. So this has been immensely helpful. But it also reports all kinds of errors which are probably not relevant for us. And if you take this is pretty much the same sentence, but the noun has changed. But Wikipedia is going to have a bunch of changes in the nouns, which is not really interesting for us. So I have created in the actual process, I've created an exceptions. So we don't filter out all the noise, which is probably not relevant in the actual grammar error correction process we are aspiring to have. So this was the method which basically was applied in the raw filter, which is an expensive process. I'm not going to run this. I will show you the output of it. So once you run that, the parallel, the data that's going to have the pair of the data as well as the edits. And it basically looks something like this, the process data frame. I can show you that. Yeah. So look, it's basically going to have a column of errors and no errors, right? So wherever you don't have any kind of grammatical errors or no grammatical errors is obviously a paraphrasal change or a stylistic change or something like that. We don't know what the differences are. But the examples I want to show are, it sounds like nitpicking, but I really wanted to show some good examples which actually says that errand is useful in capturing the errors which we are really interested in. Obviously, you can see the word business is misspelled, the word vouch is misspelled, and so it basically comes back and say, hey, there's a couple of different spelling errors, and then there is a verb form error here, right? So the output of this step is basically take the pair and then annotate or tag the errors available. And then the next step is to make sure that we discard all the sentences which are not, all the sentence pair which are not so useful for us, which basically filters out. That's what is happening here. And once you filter out based on the empty or non-empty value here, there's another flag here which basically says is it or not. And then that's what it is showing here. And as you can see, this is one of the examples, which is the verb form. So Ashley attempts to reveal, as it should be Ashley attempts to reveal. It basically says Ashley attempts to reveal. So you can take these examples, run these scripts, and you can look at it, and then there is a lot of different errors, and you can see why this distribution makes sense. This was after I ran the pairs, tag it, filtered it, and then I basically came up with the spread of the error. That's what the last step is, to say, like, split the error forms and then come up with the error forms to have a simple count of it, and then plotted it circling back. This is what I had. So obviously I saw there are some blind spots in the kind of error in terms of counts. For that practical purposes, I included the corruption data. So coming back to the pipeline, which we quickly saw, which is basically what we ran through. Errant is the centerpiece of it, which basically helped us filter the data and get that, and then you can just detokenize it. And then once the data is there, it is pretty much a sequence to sequence modeling, and you can think about any encoder decoder model, language models like DeFi or BOT, if you have in mind, or if you are a big GPT aficionado, you can still frame it as a conditional text generation using GPT, any one of them, GPTX models. So either way, it's just given a text, what is the target text? Using the pairs, you can frame it as a text, free-form text generation or a conditional text generation. So I have an annex which I want to take like 10 minutes and talk about it. But before that, I think it's a good point to pause and take questions. If you guys have any questions, I can talk about it. Otherwise, we can look at the next section, which is basically an appendix kind of a section, which I want to speak about it for 10 minutes. There, emoji translate. Okay. Did you train this on Colab? There's a question from Gauri asking, did I train this in Colab? Yes, the initial versions was in Colab, but the more the data coming in, like once you have more than 500K, and then if you train it, you obviously have to come up with some kind of technique, like gradient accumulation, to make sure that the batch size is, I have to either reduce the batch size really small, the batching really small and do gradient accumulation, or I really have to go for a bigger thing. So I ran out of Google Colabs, even though the pro version I used, I ran out of capacity. I had to use a VM. So that answers, that I hope answers Gauri's question. Did you touch the vocabulary at all? Drew, can you speak, clarify vocabulary of the
the
pair?
model vocabulary basically. So I was curious because there's a lot of like spell errors in addition to grammatical errors, and I was wondering how the token vocabulary played into that.
Sure. But if we look at the examples, we can look at it. But the foundation, we did not touch the vocabulary because we are still doing transfer learning, and there is a wealth of knowledge is locked in the base model in terms of vocabulary. For instance, take T5 base. We are just writing on top of the vocabulary that is available on top of that. We are not doing anything specific to augment the vocabulary of the base model using the vocabulary or additional words harvested from the pairs. If that's what you mean, I'm amending or augmenting the vocabulary base model on which we are doing the fine tuning. I hope that makes sense. If I'm gonna wait for a minute to see if anybody has any questions up until now, or we can go to the next section, which is just, like I said, it's just a 10-minute, like a thought experiment. This is again a question, if I can throw it out. There are a bunch of models, like, people are in awe and shock with GPTs and, models. And Did you guys ever thought about why we need to fine tune a model? Because we have large language models, and given grammar is a canonical and basic construct of a language. If at all, if you say by language model, the language model has to encompass grammar error correction. Why can't grammar error correction be a simple task a language model like GPT or something else can solve? Anybody has any thoughts? If you can step up, it'll be good. If you have any thoughts, why can't we simply abstract complex grammar error correction with the most complex large language model? Anybody has any thoughts? I hope not. I guess not. So I'm gonna move on and say. So here's my case. Like large language models. As of today, these are the I mean, there are a bunch of language models available. There are auto-encoding models, auto-regressive models. There are encoder-decoder models, and you can look it up. And then Hugging Face, you name it, and Hugging Face has it. You guys all know the turnaround time between academic research showing up in Hugging Face and industry research showing up in Hugging Face. But still, these are the largest models, and you can look at the training parameters, and then you can look at the training data size, and then obviously. It looks attractive, and it looks tempting to see why not, or what these models do learn if they cannot learn the basic construct. Lack of task overlap. I got a comment. I'm just reading it from the question. Lack of task overlap with grammar correction given the training data set. That is interesting. Task overlap. Yeah. Drew says a possible reason why large language models cannot do grammar correction is a lack of task overlap. But just to ask you guys back, it isn't, if you look at it differently, if a language model by definition cannot solve grammar, what is it learning actually, right? Then it comes up with, then we have to come up with a lot of questions, and we have to see the efficacy. Is it really learning something, or is it really getting good at it? So I did some research, and I not research in a traditional sense. I looked around, I digged around, and I just wanted to know what actually is getting learned. And then I still encourage you and recommend you guys to go back to the Stanford model, Stanford paper on the opportunity and the risks of foundation models. They just have phrased the pre-trained models as foundational models. So as you guys all know, that typical autoregressive language models are not learning anything in terms of anything special. In terms of what they're learning is they are getting very good at given the word, they want to predict the next word, right? So they are basically based on the premise of a causal language modeling. They are autoregressive for a reason. Given the word, what is the next word? Which is a probability chain rule, which we're highlighting here. So if you give a sentence, it basically has learned it like this, and it can give you the probability of a sentence, given a sentence in a particular data set. And then people back a couple of years back or a year back, they came up with a specific construct called perplexity, which is a measure of the language model on the data set, which sits nicely on top of the concept of entropy. So autoregressive models this is what they are getting good at amongst different things. So basically, causal language model is making them as a very good next word prediction. So anything that is coming under the rubric of next word prediction, they're really getting good at. So I just want to revisit the complexities in grammar correction, and then do one more quick walkthrough if we have the time. Aarti, I just want to quickly check how am I doing on time. Do we have another 5-10 minutes, or
Yes.
how am I doing on time?
Yeah, you have another 10 minutes.
All right. So yeah. So to revisit that, these are the nuances, right? So what does that do? I did promise that the complexities of the language does make it a higher order task. Why a grammar error correction is possibly a higher order task, and what is a higher order task, right? So what is happening with the advent and emergence of complex language models today is a lot of simple tasks are or should I say not simple, it could be complex to build, but a lot of tasks, as you can see, are subsumed by the capabilities of large language models, and they are fully abstracted away, and they are repeatable, and they are completely reliable. For instance, if you take classification, Hugging Face claims I can reframe a natural language inference task to make a classification, zero-shot classification, and it reliably works, and it's completely, you can take it as a perfect model, and then you can present a classification output to the user, take active learning inputs and make it as human learning, human in the loop learning input, and then fine tune the NLI model, and then a perfect reframing can be done to make a zero-shot task transfer. And then people argue that a Q&A task can be used in a zero-shot setting to transform a Q&A task into a relation extraction or information extraction. So as you can see, where I'm going with this is there's a bunch of tasks that are already getting effectively and fully abstracted away by zero-shot, in the zero-shot or few-shot setting. So let's take a quick look at what do we mean by that, and what are actually the blind spots of are everybody in the group? Oh, I have a question. It might be able to give you probably grammar correctness, but correcting the grammar is more of a paraphrasing task. Okay, interesting. So Drew, just indulge me for a minute, and you will be surprised. There's a bunch of things you can see. I hope most of you are had a chance to play with these large language models, like the Jurassic from the AI21, and OpenAI has got a playground, and they have made a very kind of pretty bold statement to say that they have they have pre-packaged tasks, and they do say there's a grammatical standard error correction task that they can support. And as you can see, like they have given a canned example, which basically is a simple statement which has got some a word order plus the verb errors, and it says obviously it fixed it, right? So obviously it looks like the error is fixed, and in a zero-shot setting, right? So especially to Drew, it's not just spotting the error, it is actually rephrasing the error, which is pretty impressive, and it gives you the illusion that the large language models can actually fix the errors, right? So I will tell you what's going to happen here. So let's look at because in terms of parameters, what's more interesting to me is Jurassic 1 is 178 billion parameters. So obviously in terms of parameters, this is a much bigger model. So I'm gonna give the same example here and see what's happening here. This is a completely, so for people who are not acquainted with the prompt programming, that it's basically prompts are nice text tokens which you can use to tell the model without fine-tuning the model, saying that, hey, I have an original sentence and I want this sentence, can you do that? These are basically prompts engineered for a particular task, and that's what the task here is. The zero-shot task here is grammar error correction. And if you can do that, that sounds great. And she did not go to the market. So it looks like on the surface, if we broadly abstract the surface, but it looks like, wow, language models have figured it out, and they can actually do it, right? But let's not just scratch the surface. Let's go let's dig a little deeper, right? So what is actually happening is, I'll give you a different example, but where it is necessarily a sentence like this: we should go, we go should after them, right? And then ask what's happening. So obviously it says, hey, we should go after them. That's the right thing. And same is the case if you use the same prompts in this model, which is purportedly, as you can see in the right side, 178 billion parameters. We should go after them. As you can see, they are seemingly fixing the issues, but they're not. This is one of the grammar error correctors. This is one of the companies. They are doing a great job, and I just want to quickly show what a real grammar error corrector does, right? If we just simply put there, if I fix this, it says we go after them. It is not saying that, hey, go and shoot are in the wrong order. I'm gonna fix the order for you. That's not what it's saying. It says shoot is redundant, and it basically the error here is if you highlight it, it says remove the shoot, right? So same is the case with the model that I was. I mean, I have already ran it, obviously. So it says if we say we go shoot after them, the correction is we go after them, right? So you can see a fundamental difference in between a grammar model and a model which has gotten good at the next sentence next word prediction, right? So it's not an order error, right? So it's basically masquerading as a grammar error corrector when in reality it is not. I'm going to give you a couple of more examples to run my point, right? So let's take the same example. Let's take the same prompt engineering and use the word. So here, obviously, the error is when you have a noun which is a plural, the apostrophe is implied, which is not supposed to have girls, an apostrophe, and an S. The correct version is you're supposed to have just girls with just an apostrophe and not the S, and that's what the grammar error models are giving you. Okay, the model is loading. While it is loading, I'm going to show you what the language models are trying to do with that. Right? They have no notion of the apostrophe error. It is an issue. They just repeat that because according to them, in terms of next word probability, it's perfect, right? They don't see anything wrong here, right? So and then this is only one prompt, and then I played with the prompts, right? So I said like, how about there's a problem in the prompt? I played with that. I'm going to talk about the change of prompts in a moment because prompt engineering is a lot more important. We have to probe the model, even though they are large language models. We can probe the model externally without fine tuning, but we have to be very creative in prompt engineering. But before getting into that, I'll give you one more example of this. Apostrophe is a big deal apparently in language, and obviously here it is. Here the sentence basically says it is the team's first win, and the ITS is either should have apostrophe. It should be a contraction of it is, and you should that will be recognized by a language model. That will be recognized by a grammar error correction model, one which is trained on grammar data, as you can see. So it is either it is or it was, right? So yeah, here the model is loaded. As you can see, the apostrophe is removed in gram former, and same is the case with it is the team's first win if you ask for a grammar error. So it is the gram former is basically recognizing it's a contraction. It should be it is and not an apostrophe, not it's, right? So the difference is slightly complicated. I can show you guys. So the its and its is one of the complicated errors in English. It's commonly confused. You can look it up on. But the so-called language models are not recognizing the error. So it might sound like I'm cherry picking, and because in some sense we have to cherry pick because there are 25 different categories of errors in terms of error types, and then there are different instances of each of those errors. And if you want to really call a language model that has understood the concept of grammar, we have to check every single example. And these are a couple of examples I wanted to show what's happening. Another example I can show you is if you so for the want of time, if you can change or play with the prompts, it performs even better. I will leave it to you guys. And also this is only 0-shot setting, and then you can do also a few shot setting where you can give some examples, right? For instance, if you give this prompt, right? So where I have not only given a sentence and a correction, I have a different, as you can notice, there is a different prompt engineered. It's not the default prompt. So if I give an
sorry to interrupt. If you can wrap things up in the next couple minutes.
Sure, I'm gonna, yeah.
Awesome.
So if you give the example here and to show exactly what the problem is, and if you ask the model to correct it, the model can actually, give me a second. So if you can, as you can see, if you give an example as a few shot with one example and different prompt engineering, the model does, you can actually probe the language model, change it. But the larger point here is, for the want of time. So this is what we mean by, this is what I meant, and this is my argument, right? Like, at best, if you're going to do a zero shot or few shot with large language models, you can cover 30 to 40% of an higher order task, and you still need fine tuning. That's my point. Grammar correction, I have tried to do it. Even if you go with different combinations of few shot and zero shot, there's only so much you could do with that. In some sense, that's what Dhruv said. There is a fundamental overlap problem. So large language models appear to fix simple errors, which are coming under the rubric of next word prediction, but they are not actually, they're masquerading as a language grammar error correctors. They are not grounded on sound linguistic principles. That's the large point. So large corpora, they are used to train on other model. A complex model architecture is not alone enough for doing that. So there is no upshot. Also, if you see that if you do large language models, in spite of substantial prompt engineering effort, we will be ending up with a suboptimal solution, and which cannot be improved over time because you are not fine tuning. You are basically probing the model from the outside, which is also huge models, which will cost you high inference cost, and hence that's not viable. So I just wanted to run this with you guys. So the data bottleneck can be easily solved by reframing the problem with wiki edits as I've done, and that's it. So in terms of next steps, just want to see like what will look like if we have more data budget, model budget, bigger base models, and then if you throw more wiki data, and probably I have thoughts to benchmark this with the Gector model, which is from Grammarly, and try to extend Iran for other languages. These are some of the things I have in mind. Some things that piques my curiosity is, looking at the distribution, could there be source of bias? Is our hypothesis okay? And what could be the problem by going with 100% Wikipedia data? And what will the typical distribution look like? And yeah, so those are some of the things I have in mind. This is my next step, and I think I'm done. Sorry, I ran a couple of minutes outside of my given time. If you guys have any questions, do let me know.
Awesome. Yeah, thank you so much for presenting.
Thank you.
Yeah, if you want to maybe post your email, or we can continue having a Q&A in the last couple minutes of the chat or of the conference. But yeah.
I would just like to add, Aarti, I think
sure.
Thanks for this is I know these are odd hours for you. Thanks for making time for us and presenting.
No worries.
Yeah, definitely. Thanks for making the time.
I hope at least you guys had some takeaways from this, and that will be good. If you took away at least one thing from this, that will be good, because you don't really have to have an expensive data generation process for correcting grammars. That's one thing. There is a question, Aarti, if you don't mind, I'll just take this one question. Wikipedia editors may already be well read and less likely than the general population. That's the point we made. Wikipedia editors are it's a community. They are not experts in they are experts in the subject matter of the domain. For instance, if people are writing about astrophysics, people who don't know anything about astrophysics are not going to touch the Wikipedia page. Probably they'll come with a sound knowledge in the subject matter itself, but not necessarily. Think about this, Gauri, for hypothesis. There could be a non-native speaker sitting in Poland or Russia, but they could have a fantastic knowledge in the astrophysics. They could still be writing Wikipedia pages. So I don't think that hypothesis will hold good, that all Wikipedia writers in the community are proficient in English. I don't think so, but that's my humble thought. I will leave it to you.
Yeah, I didn't mean all, meant more like the distribution may be skewed, but yeah, I get your point.
Distribution, again, right? That's what I'm saying. Unless you really look at the distribution, you probably won't know how it's going to look like. There is proficiency in the mix. there is domain in the mix, and there is who is doing it, who is correcting it. I really don't know. I don't want to speculate that. If you are interested, you probably can take it offline and look at it. Matt has a feedback, I believe. Demo was interesting. My suggestion is to start from demo if you present again. Okay. Thank you. Thanks, Matt.
Awesome. Yeah, thank you.
Demo, by that you mean the OpenAI demo or the notebook demo?
Matt, I think a question for you.
Okay. I mean, if you have further questions, do drop me. My email ID will be with RP, and I can make this presentation available for you guys. And if you do have further questions, do write to me. Thanks for listening.
Thank you.
Yeah, thanks again.
Yeah.
Great.
Stop sharing.
Yeah, I think we have about 9 minutes left in the conference, and we have one presenter who's signed up for a lightning talk. Matt, you wanted to talk about auto-parallelizing engine for Python pandas?
Yeah, thanks. Appreciate it. Let's see. I won't. Well, I could throw up slides here. I'm trying to find the video button. There it is. Sorry. Yeah, I just wanted to make you guys aware. I've been working with a company that spun out of Intel Labs and Carnegie Mellon. We are focused on the issue of helping particularly people that have written models in Python and pandas, or scikit-learn, or Python with SQL in it. How do you get that into production in large scale use cases? So what we built is a inferential compiler that takes pandas code and auto parallelizes it and deploys it. It's called Bodo.ai. We're running in production at a big company that starts today. It's you can easily run take your pandas code and auto parallelize it on up to 10,000 cores. So I wanted to make you aware of it. It's the way it actually works is via a JIT compiler, similar to Numba. So you just put the Bodo.jit notation around the functions that you want to auto parallelize, and then it does the work for you. One of the things that we're finding in some of our early customers, like at 7-Eleven, is that it really cuts down on the amount of DevOps engineering you're doing. If you're using Spark SQL or PySpark or something, and you're constantly tweaking the size of the cluster or changing the queries around in production. That's one of the big benefits of it, is it just takes it directly to machine code that runs on your cluster. So I don't know if that's appropriate for you. Let me see if I can share slides real quick. But I'd be real interested in anybody that wants to talk to those guys. While I'm at it, on the topic of natural language processing, I'm also working with a company called Urvin, URVIN.ai. We built the text classification model that classifies all the entries on the eBay for tax purposes. So it takes any description that you type in and does that. So that's another instance where we're bringing AI at high scale to bear on these machine learning problems, because at least what we've seen in production is when you have these, sometimes you get the machine learning model and it works great, but it doesn't work great in production at scale. And I guess I heard that a little bit in the Sensible presentation too, and I was wondering if Bodo would potentially help you guys. I mean, one of the challenges is when you want to make things go in real time, can you can you accelerate things enough? And the core of, sorry, it's late. The core of what we're doing with Bodo is taking Python, which is easy to write, pandas, which is one of the most popular libraries, and translating it directly into MPI, which is the parallelization language that most supercomputers use. So we're doing all that data engineering for you in an automatic platform. You can, there is a community version of Bodo. That's available. Really nice, lets you auto parallelize on up to 4 cores. And then there's also an Amazon AWS version. It's available in the AWS marketplace. And I'll give you 4 of your minutes back. I really appreciate the chance to talk to you guys and look forward. We just moved to Raleigh, so I'm just looking forward to meeting some of you guys in person and getting to know the data science community here.
Yeah, great to have you, Matt. Looking forward to seeing you in our upcoming meetings.
I look forward to it. Thanks for having me.
Awesome. Well, thanks everyone. Thanks for joining the September session of the PyData conference. Just a quick reminder that our next conference is November 3rd. But yeah, see everyone there. And if nothing else, we can end the call.
Yeah, real quick, if you want to contact me, I'm just Matt, M-A-T-T, at bodo.ai. Thanks.
Great.
And we are hiring.
Have a good night.
Thanks, everybody.
Thank you.
Right.
Bye.